for example 47, we have x to the fifth times the natural log of x. Okay, because I said the word times, it means we have a product, which means we need to use the product rule. So let's use the product rule to find the derivative of x to the fifth times the natural log of x. All right, product rule says derive the first term. We know that the derivative of x to the fifth is 5x to the fourth. Keep the second term, so we're going to keep the natural log of x, plus, and now we swap roles. We take the derivative of the second term, which is 1 over x, and we keep the first term. And we keep the x to the fifth, and we multiply that by 1 over x. That answer is 100% correct. Some of you are looking at that last term and saying, well, if we have x to the fifth times 1 over x, isn't that really x to the fourth? You would be correct. So we could also see 5x to the fourth natural log x plus x to the fourth. And yeah, you could factor out an x to the fourth of those two terms. We're not going to go any further. Just know that these two are the same. You don't have to go any further than the first one unless it's a multiple choice question and it's requiring you to do so. Okay. What's even more likely as a multiple choice question is an example like number 48, where we have the natural log of an inner function. And again, because I'm saying the word inner function, your minds are thinking, oh, this is a situation where we have to use the chain rule. They like to do chain rules with natural log on the exam. Okay, so how does it work? Well, the derivative of the natural log of x is 1 over x. Okay, so that's our template, if you will, 1 over. Our outer function is natural log. Our inner function is this polynomial. So let's do our chain rule. Derive the outer. 1 over. That takes care of deriving the outer part. Keep the inner. The inner function is our 2x squared plus 6x minus 3. So we're going to keep that where x would normally go. X is normally in the denominator. Now the polynomial is there as well. Okay. Multiply that by the derivative of the inner function. What's the derivative of 2x squared plus 6x minus 3? Well, that's a polynomial that you've been deriving for a while now. That's going to be 4x plus 6. That's our derivative for the natural log of 2x squared plus 6x minus 3. Now, a couple of things to keep in mind. Lots of students think because there's natural log in the problem, there must be a natural log in the derivative. And that's not the case if there's only one term and it involves a natural log. Right? There is no natural log in our derivative. The natural log is gone because we've taken the derivative. And it goes back to the original. Natural log of x's derivative was just 1 over x. There was no ln x in there. Okay? When we derive a natural log function, there won't be any natural log in the derivative. Okay? Second thing to keep in mind. Some of you are looking at this and saying, can I take this 4x plus 6 and move it up into the numerator? Absolutely. And in fact, you can do that right away. You don't have to do this in 2 steps. You can just say, hey, we put the derivative of the inner function in the numerator, and then we put the original inner function in the denominator. Oops, that's a minus. Okay, and stop right there. That's it. There's our derivative.